Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. For this question, it's really important that we understand what the words sum and product mean. Now, sum just means add, and product just means times. So we're going to start by adding the 5 and the 4. So that will equal 9. And then what we're going to do is find the product of 9 and 7. So we're going to multiply them together. 9 times 7, which is 63. So our answer is 63. So with this question, we need to first of all count how many sides this polygon has. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 sides. And we just need to know that a 10-sided shape is a decagon. Now we are expected to know all of the names of shapes between 3 and 10 sides, so if you don't know them already, just sit down and learn them. For us to create the largest number, we need to pick the biggest digits for the start of the number. So the biggest digit is 7, then 6, then 4, then 3. But the question says it wants the largest even number. So we need to just swap the last two around to make sure that it is even. So our answer is 7,634. So we've just got to know some vocab. Faces are where you could lay your hand flat on a shape. Then you've got edges where you can run your finger along. And then vertices are the corners, the bits that you would stab into your finger. So we've got 1, 2, 3, 4, 5 on the front, 6, 7, 8, 9, 10, including the back ones. For this question, we're going to have to remember BIDMAS or BODMAS. So we're going to first of all look and see if we've got any brackets. Well, we do. We've got the 11 squared minus 21 in brackets, so we're going to be looking at that bit first. Inside the brackets, though, we don't have any brackets. But we do have an indice. We've got that 11 squared. So we're going to deal with that first. So 11 squared is 121. So we've got rid of the indice, but we're still looking at the bracket. So we're going to do 121 minus 21, which is going to be 100. Now we have no more brackets, no more divisions, but we do have a multiplication. So it's going to be 300, and that's our answer. This question's all about like terms. So what we can do is we can add this 10u with this 11u to make 21u. We can also add this 6v with this plus 4v to make 10v. We can also add this 10w to this minus 6w. So 10 take away 6 is 4w, so plus 4w. But we can't add a u term to a v term to a w term. So we have to just leave them be. So our answer is 21u plus 10v plus 4w. But we can multiply them, we just can't add or subtract them. So 55% is the same as 55 over 100. And what I can do is I can divide top one of the fraction by 5. And so that is going to equal 11 over 20. Now in total there are 20 squares here because there's 5 across and 4 down. 5 times 4 is 20. And if there's 20 squares and we're looking to shade in 11 20ths, it's just going to be 11 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Something to realise in this table we're given in this question is that the triangle has 3 sides, quadrilateral 4, pentagon 5 and hexagon 6, and that number is just 2 less than the number of faces. So basically if you've got the number of sides you add 2. So 4 plus 2 is 6, 5 plus 2 is 7 and 6 plus 2 is 8. So if we've got 20 sides and we just do the same thing, so we're just adding 2, then we should have 22 faces. So our answer is 22. So we're going to start off by working out what 100% of 120 is. Well, that's obviously just going to be 120. And we're trying to get to 6%. So we always start off by working out 10%. It's always normally useful. And we just divide that 120 by 10, so we get 12. And we try to get 6%, so it'd be nice if I knew 5%. And 5% is nice and easy because we just halve that 10%. So that'd be 6. And if we got the 1% as well, we can get to the 6%. So to find out what 1% is, we just divide the 10% by 10 and get 1.2. So to get the 6%, we're going to add the 5% and the 1%. So we're going to add the 6 and the 1.2. And so we just do 6 plus 1.2, which is just going to be 7.2. And that's our answer. First thing I'm going to do is just copy down this diagram to the side here, just so we can kind of see what's going on a little bit more. Extend this a bit. Okay, so the first thing I'm going to do is convert the measurements here into centimetres. So we've got 3,000, 5,000, 1,000, and we've got 6,000. And then I'm going to look at this scale here. Now this says that 1,000 in real life is 1 on our scale drawing. So this is just going to be 3 centimetres divided by 1,000. This is going to be 5 centimetres, 1 centimetre, and 6 centimetres. And then let's draw the diagram. So I'll do 3 centimetres. This is going to be 5, and so it's 1, 2, 3, 4, 5. Got 1 across here. And I'm going to do the left hand one, so 6 down. 1, 2, 3, 4, 5, 6. And then just join them up as it shows on the diagram. And there we go. So what we need to do is find out where the graph is at its highest, and so it's highest here. And so if we go down from there, we find out what year it is. Well, these years seem to be going up in 1, so that's 1950, 1951, 1952. So the answer would be 1952. So to do this question, you just need a piece of paper, a ruler and a protractor. And the first thing we do is we draw the 11 centimetre line. And my one will not be 11 centimetres for you. It is on my screen, but because depending on what device you watch this on will change obviously its length. And what I'm going to do is I'm going to put my protractor on this end here. So I've kind of got my protractor here. And I'm going to just have a look at getting 39 degrees. Now you've got to be careful because 39 is on the inside, and I'm just going to do a dot. So always look to see which one, the inside or the outside of the protractor, starts at 0, and the inside should start at 0 from this side. And I'm just going to draw a line that connects the end of that line and the dot. Like so. Now just you can keep it going. Right, the next thing I'm going to do is put my protractor on the other side. So my protractor is kind of here. And I'm lining up the crosshairs with this point here. But this time I'm measuring on the left hand side, and I'm looking at 59 degrees, which will be here. Get my ruler. Now this time I can actually stop where it hits the other line. So keep going and then stop where it hits the other line. This screen's not perfectly calibrated, so it's difficult to do precise work, something like that. And then what you can do is you can get your rubber and just rub out the extra bit of line that we had to do. And so this is our 39 degrees here, and you don't need to label this on the diagram, but just so we know what we're doing. And it says when it's completed, measure length x. So I'm going to get my ruler out and I'm going to measure this length here, this one here, and it is about 95 millimeters. So the answer for me is 95 millimeters. Now there is some level of precision. You're not going to get necessarily exactly 95 millimeters. When we mark these questions, we normally have an overlay and we put it over the top, and if it's roughly the same, and you can make small errors because nobody's perfect, and my diagram definitely is not perfect, but there are allowable small errors here and there. I'm going to write this expression by putting a time sign in, so 5 times x plus 8 times y. Rewrite it again, but instead of x we've got 4, instead of y we've got 3. So it's 5 times 4 plus 8 times 3. 5 times 4 is 20, 8 times 3 is 24, and 20 plus 24 is 44. So we're asked to reflect this shape along the line y equals x, and y equals x is a diagonal line where all the x values are equal to the y values. So at the bottom here we've got x is 10 and y is 10, so that coordinate would be 10, 10. And then obviously this coordinate 4, 4, etc. So we need to reflect it across this line. And so if I pick a point, I'm going to pick the top one. We can see it goes 4 diagonals to hit that line. So 1, 2, 3, 4. So it will go another 4 diagonals. So that will be one of the coordinates there. And I'm going to do the same with the bottom one. So 1, 2, 3, 4, 5, 6 diagonals. 1, 2, 3, 4, 5, 6 diagonals. So it will be there. And then finally, I'm going to do this slightly harder one. So we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Kind of goes over the other one. Ends up here. So if we join these up, and we need to label it B. I'm going to start by just copying out the question. Now the word solve means find out what x is, and the first thing we do when we see solve is draw lines to the left and right of our equal sign so we can solve it. So there's two things stopping us from having x on its own: this over 5 and this take away 10. Now that take away 10 isn't in the fraction, and normally I would say to get rid of the fractions first, but because that take away 10 is just sitting there on its own, we need to get rid of that first. So what I'm going to do is the opposite of take away 10 to both sides. So we're going to add 10 to both sides. That will leave the x over 5 on the left hand side, and 0 plus 10 is 10. So we want to get rid of this over 5, but what does over 5 mean? Well, it means divided by 5. So the opposite, the inverse of divided by 5 is times 5. So I'm going to do that to both sides. So we're left with x on the left hand side. 10 times 5 is 50. So x equals 50. To work out the circumference, we need to first of all work out what the diameter of this is. And to do that, we just draw a line across the circle, and we can see the diameter is twice as big as the radius. So the diameter is going to be the radius times 2, which is 28. Formula for the circumference of a circle is just pi times the diameter, which will be pi times 28. Now to write this in terms of pi, which the question asked for, we just put the number first and then pi. So it will be 28 pi. Another way of writing a to the power of 6 is a times a times a times a times a times a. And another way of writing a to the power of power of 5 is a times a times a times a times a. Now you might notice that altogether there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 a's that are being multiplied together. When you multiply something together 11 times, you get that thing, which is an a, to the power of 11. An easier way of doing this is just adding the powers. So when you've got the same base, which we do here because they're both a, you just add the powers together. So the question asks us to work out the bearing of the cinema from the train station. So from the train station means we're at the train station and we're looking at the bearing, which are always from north going clockwise, of the cinema. So it's this one here. To be able to do that, we need to remember a few bits about parallel lines. So we've got a parallel line here, and all lines pointing north are always parallel. And these angles make a kind of C with the parallel lines. We need to remember that they are interior, allied, or co-interior, depending on how you say it, but they are interior angles. And what we know about interior angles is that they add up to 180. So we're going to call this x, and we're going to say x equals 180, take away the 98 there. And so we just put on our calculator, or do it in our head, 180 take away 98, and you get the answer of 82. So we know that this angle here, instead of x, we know it's going to be 82. But the way we show bearings is with 3 digits. So it's going to be 0, 8, 2 degrees. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13, which is 312. Next we're going to do B, which is this one at the top, and it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104, and that will give me 1,216 centimeters cubed squared, because it's an area. So the rules of indices state that if you have a power inside and outside of a bracket, we just multiply them together. So it's 10 to the power of minus 12 times minus 12. 2 negatives make a positive, and 12 times 12 is 144. So I'm going to start just by writing out the equation, and I could put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says expand your answer fully, so we're just going to expand the brackets, 7m plus 70. Sometimes it's easier with these questions to multiply both numbers by, say, 10 or 100 or 1000. So if we look at the 0.06, if we times that by 100, it would make the question a lot easier. But with a division, if you times one of the numbers by 100, you have to times the other one by 100. So we just go times the 30 by 100, and times the 0.06 by 100 to make that 0.6. And this actually is the same calculation as 30 divided by 0.06. The reason being is that you can write that as a fraction. And you know with fractions, you can just times the top by something and times the bottom by something. It doesn't change the fraction at all. It just keeps it exactly the same. So we're going to use the bus stop method to find out what that is. So we're going to divide that out. 6 doesn't go into 3, so carry that. 6 is into 30, go 5, 6 into 0, 6 into 0. So that's going to be 500. So in this question we are told that the centre of enlargement is at 6, 4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be -4, 1. The important thing to realise in this question is that we know a female has been selected, so we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female has been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here. The question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 meter and the 35 meter. And essentially what this question is asking is what is the highest common factor of 25 and 35. So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these. So 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. The formula y equals mx plus c includes this m, and the m means the gradient. So if we're looking for something that is parallel to y equals 9x plus 18, we're looking at this number here. And for it to be parallel, it needs to have the same gradient. So we could just write y equals 9x plus or subtract anything. Or we could just write y equals 9x. I'm going to say plus 5. So Pythagoras says that a squared plus b squared equals c squared. And the c is the one opposite the right angle. So I'm going to label this A and B. So it'd be 5 squared plus 12 squared equals C squared. 25 plus 144 is equal to C squared. And then 25 plus 144 is 169. And then we're solving to find out what C is. And we're just going to square root both sides. So square root of 169 is 13. So C is 13. So we're told that from 14 people who liked football, so we've got 14 people here who said yes, they do like football. So we can fill up the 14 here. Now, we're told we started with 31. Therefore, if 14 liked football, then 17 must have not liked it. Carrying on the sentence, it says 4 like rugby. So 4 of those liked rugby. And we had 14 to start off with down this strand. And so that must mean that we've got 10 who don't like rugby. So of those 14, 4 liked rugby. So therefore 10 must have not liked rugby. But what about the bottom section? This part here. We've got 17 who didn't like football. Well, it says from the people who did not like football, 6 liked rugby. So we've got 6 there, and that must mean that we've got 11 who did not like rugby. So in this question, we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now, if I just rewrite this, 2 3/4 can be written as 2 plus 3/4. Plus 2 plus 2 1/5, or 2/5. So we can add the 2 2's together to make 4, and then all we need to do is add the 3/4 and the 2/5. So when you add two numbers with different denominators, what we need to do is get the common denominators, and we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20, and 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top. So times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20. So we times that by 4. And so we've got times the top by 4 as well to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it'd be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 3/20. And we can add the 4 and the 1 together to make 5 3/20. So the answer is 5 3/20. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So we're timesing them, so 10 times 10t, 10 times 10 is 100, so it'd be 100t, 10 times 4 is 40. So our answer will be 100t plus 40. Now, between A and B, the shapes haven't changed size, so it's not an enlargement. They haven't rotated or they haven't mirrored, they've just moved. And the word we use for that is translation. So this has been a translation. And for a translation, we need to find out how far right they've gone and how far up they've gone. So we pick a point that we know on both shapes, and I'm going to pick the top left, and we count how many jumps we jump to the right. So 1, 2, 3. So we do 3 jumps to line it up with the other one. So there's a 3 at the top to say 3 to the right, and then we count how far up we have to go. So 1, 2, 3, 4. Now we've actually had to go down, and whenever you go down, it's like having minus up. Okay, down is minus up, so it's going to be minus 4 because there were 4 jumps. So we know that James knows that he has a square, so we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. The rules of indices say that when we multiply 2 numbers of the same base, and the base are the big numbers, then we add the powers. So we're just going to do that to the top fraction here. So it's going to be 5 to the power 13 plus 4, which is 17. And then that's going to be over 5 to the power 5. Now, what a fraction is basically is a division. So it's 5 to the power 17 divided by 5 to the power 5. And the rules of indices say that when you've got 2 numbers of the same base, which we do here, and we divide them, we take away the powers. So we're going to do 17 take away 5, which is 12. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So W therefore equals 4. To prove triangle congruence, you're going to have one of 4 answers. You're either going to have RHS, SSS, angle, angle, side, or angle, side, angle, and the last one, side, angle, side. So those are our options. So we've got to figure out what we have in this question. Well, we have a right angle, so an angle or right angle. We've got a side, which is actually the hypotenuse, because we know the hypotenuse is opposite the right angle. And then we just have another side. Now, it's not going to be SSS because we don't have 3 sides. We do have a side and an angle and a side, but the 2 sides are not next to the angle, so it's not going to be that one. And we don't have 2 angles, so it's not going to be this one. So the last one is RHS, which is right angle, which we have, hypotenuse, which we have, and side. There are a few different ways of finding out product of prime factors. I prefer using the bubble technique. So we just write the number out and we put a bubble around it, and we split that number into 2 numbers. So we find 2 numbers that multiply together to make that number. Now, I always pick the smallest that I can on the left-hand side. Now, the smallest I can think of is 2. And so 2 times 22 is 44. And now we think about 22, and that's 2 times 11. Now you might be thinking, why have I put the 2's in red? The reason why I've put them in red is they are prime numbers. We can't do another thing for the 2. Well, we can, it would be 2 and 1, but we'd be there all day doing 2's and 1's off the 2's. So we leave it as they are, and 11 actually is a prime number itself. So if I'm going to keep up with the theme, I can have that in red as well. Now, notice it says product of prime factors. So the prime factors are 2, 2, and 11. But the word product means times. So it's 2 times 2 times 11. Notice they're in ascending order. So it's 2 times 2 times 11. Now, if we were asked to do it in index form, we would write it as 2 squared times 11. Whenever we do these kind of questions, it's always best to convert the pattern into numbers. So we're just going to count the dots. So we've got 2, 4, 6, 8, 9 in the first one, 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So our sequence is going 9, 13, 17. And we're going to see what it's going up in. So we're adding 4 each time. And that means our sequence will involve 4n. And then what we do is we go backwards 1 to find the 0th term. So we're going to take away 1. So 9 take away 1 is 5. So the 0th term is 5. And the 0th term just tells us what to add on to the 4n. So 4n plus 5 will be our answer. We can rewrite this question as 2 over 3 divided by 20 over 1. So whenever you have an integer, it's just the same as that integer over 1. Now the rule is that we're going to keep, flip, and change. So we're going to keep the first fraction as 2/3, change the divide to a times, and flip the second fraction. Then we multiply the tops and multiply the bottoms. We can actually halve top and bottom here, and it does ask us to simplify it if possible. So our answer is 1 over 30. So with each of these pools, try and imagine it being filled. So pool A, first of all, we've got water coming into it, and it's actually going to go quite quickly initially, and then it will hit a point at the end where actually it will go really quite slowly because it's a wider pool. So we would imagine that the graph for pool A would actually go quite quickly at the start, and then at the end it would go much slower. And that doesn't really describe, the red graph doesn't really describe that at all. So for pool B, we start off actually quite quickly because it's quite thin, and then we have a wider bit here, so it will go slower here, and then we go quickly again. So we need a graph that starts off quite quickly, then goes slowly, and then goes quickly. And the steeper the graph on our depth time graph, the faster it's filling up. And that red line doesn't really describe that either. Pool C, however, we can see it goes slowly at the start. And then because it's thin, it will go quicker. So nice quickly. And then it will go slowly again. Well, that is a perfect description of the graph that we're given. So the graph we're given is definitely going to be for pool C. So we're looking to write a formula for the cost in pounds of hiring a microwave for X amount of days. So the cost is C, so it's going to be C equals, and it says it's going to be 55 pence a day. Now it wants the answer in pounds, so we need to convert this 55 pence into pounds. So that's going to be 0.55, and it's going to be 0.55 times the amount of days. Well, it says the amount of days is X, so it's going to be 0.55x. Then it says that there's just a one-off cost of £15, so you're going to have to pay £15 regardless. So we're just going to add 15 onto that. So the answer would be C equals 0.55x plus 15. I'm just going to write the question out, so we've got a little bit bigger writing to play with here. And it doesn't actually matter which method you expand these brackets with. I'm going to use Smiles and Rainbows. So we multiply the 8 by the 10x, which will make 80x, and multiply the 8 by the 4, which will make 32. Now here we've got a minus 5 on the outside, so we do minus 5 times 8x, which is minus 40x, and minus 5 times minus 4, which is actually plus 20. And a lot of students will write take away 20 there, but that is a minus 5 on the outside of the brackets there. So it's minus 5 times the minus 4 there will give you a plus 20. Then 80x take away 40x, which will give us 40x. And 32 plus 20, which would be 52. So our answer would be 40x plus 52. The most important first thing that we do is whenever you square something, you times it by itself. So we're going to rewrite this as x minus 15 times x minus 15. And then the way we approach this is exactly the same as we've done with the other ones. We're going to do a multiplication grid. And we're going to do x minus 15 at the top, x minus 15 at the bottom. Then we're going to do x times x, which is x squared, x times minus 15, which is minus 15x. Same again here. And then we've got a minus times a minus, which is a positive 225. Put all the terms together. Now you can see here that we've got the x terms here that will add together. So that would become minus 30x plus 225, and that's actually our answer. So it's x squared minus 30x plus 225. So we can write this as a fraction, so it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into two fractions, so 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method, so 4 on the outside, and we've got 2.84 on the inside. 4's into 2 don't go, so carry the 2 across. 4's into 28 go 7, and 4's into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here, because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number, so it's 10 to the power of 13, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it would be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. So the thing we know about triangles is their angles add up to 180. So what we can do is we can say w squared plus 84 plus w plus 3w equals 180. And let's just put that together. So it's w squared plus 4w plus 84 equals 180. Now, with quadratics, whenever we're looking to solve, we want to have it equal to 0. So what we're going to do is we're going to take away the 180 from both sides, so it equals 0. So we've got the w squared plus the 4w, but we want to take away the 180 from it, which will give us minus 96 equals 0. So with quadratics, when we're trying to solve them, we need to put them into brackets. And to do that, we need two numbers that add together to make the 4 here and multiply together to make the 96 here. So just going through different numbers for 96, and you can try different ones. The first letter in the bracket would be W, first thing in the bracket would be W, and I think it's going to be, well, it's going to be a positive and a negative to get that negative there. 96 is 12 and 8, so it would have to be, let's have a think. It'd have to be a positive 12 and a negative 8 to add together to make a positive 4, and 12 times minus 8 is minus 96. That works. And to solve, we look at the left hand side first and get that equal to 0. So W plus 12 equals 0, and then solve it. Take our lines in. Take away 12 both sides. W equals minus 12. And we get the left hand or the right hand side, get that equal to 0. W minus 8 equals 0. Lines in, add 8 both sides. W equals 8. Now we've got two answers here, but it says value of W. Well, we can't have a negative angle, so we know we're looking for W to be positive, so the answer must be 8. So the way this formula works is we have M, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. So when we're doing column vectors and adding and subtracting them, we just literally add and subtract the top and bottom numbers. So A plus B minus C will be, just looking at the top, 9 plus 18 minus 9, 9 plus 18 minus 9, which will equal 18. And the bottom will be 9 plus minus 18, so really minus 18, and minus 9. And so that will be minus 18. So our column vector will become 18 minus 18. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which will be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10, 990. Now when we're looking at limits, with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. So this question is a simultaneous equations question, and so we're going to have to write down some equations. So it says 2 apples and 3 pears cost £3.80. So 2 apples, I'm going to call it A for the price of an apple, plus 3 pears, so 3p, cost £3.80. Now I'm going to do this as 380 just because it's easier to work with integers rather than decimals. And it says 3 apples, so 3a, plus 8 pears costs £7.80, or 780 pence. Okay, so the first thing I do is try and get these numbers the same. So 3 and 8, they both go into 24, so I need to make them both 24. And what some people do is they just label this A and this B. And so what we're going to do here is we're going to multiply everything in equation A by 8, so that this becomes 24. So it's going to become 8a. And so we're going to times the 2a by 8, which will be 16a, plus 24p, and 380 times 8 is 3040. And we're going to do the same with b, but this time we're going to times it by 3, so we're going to have 3b. And we're just going through everything here and we're timesing it by 3. So 9a plus 24p, which is good, that's what we wanted. And 780 times 3 is 2340. So now we've got both of these the same coefficient. What we can do is we can eliminate going downwards. Now, if they are the same, the s in same is the s in subtract. If they were different signs, so if these weren't both positive, if one of them was negative, different, the d in different is the d in add. So here they are the same, so we are going to subtract, and we're going to subtract going downwards. So we're going to start off by doing, and I can just do a little line here to show what we're doing. So we're subtracting going downwards, and we're going to do 16a take away 9a, which will be 7a. 24p take away 24p, which is nothing, which is why we did that, is to eliminate them. And then 3040 take away 2340 will be 700. Then I can put my lines in, and all I need to do now is just divide both sides by 7, and I get a equals 100. So we know that apples cost 100, or £1. We need to work out what pears cost. So I just need to pick one of the equations. I'm just going to pick this top one here, and I'm going to write out. But instead of a, we know that a is £1, or 100 pence. So plus 3p equals 380. So that's going to be 200 plus 3p is 380. And then again, I'm just going to draw my lines down, and we're going to subtract 200 from both sides. So it's going to be 3p equals 180. And then we're going to just divide by 3 both sides. And we've got p equals 60. So a pear costs 60. Now we can check this by using the other equation there. So 3 times 100 is 300, plus 8 lots of 60 is going to be, what's that, 480? So it's going to be 780. So we know that we've got it right. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. So we're asked to express TQ in terms of P and Q. Well, we've got another Q here, because all of these are congruent parallelograms. And we have a P there. So if we're starting at T and getting to Q, we can go along this path here and down this path here. So we're going backwards down Q, in fact backwards down 2 lots of Q, and then the correct way down P. So it's either minus 2Q plus P or P minus 2Q. When we multiply numbers, it doesn't actually matter which order we multiply them. So we can do 2 times 4 times 10 to the power of 8 times 10 to the power of 9. 2 times 4 is 8. And when we multiply two powers with the same base, we add the powers. That's going to be 10 to the power of 17. So our answer is 8 times 10 to the power of 17. The equation of any straight line can be written as y equals mx plus c. So we need to find the gradient, which is m, and the y-intercept, which is c, for this line. Now, we are given a clue. We're told that it's parallel to this equation here, but we're not really interested in the plus 5 at the end. What we're interested in is what the gradient of this line is, which is 11, because all parallel lines have the same gradient. So we actually know what the gradient is for the line we're trying to work out. It's going to be the same because it's parallel, so it's going to be 11. So all we need to do now is find out what that plus c is. And what we're going to do is we're going to substitute in the values of x and y for the coordinate we're given on the line. So it's going to be 46 equals 11 times 4 plus c. And we just need to solve this. So first thing I'm going to do is just times the 11 and the 4 together to make 44. And then I'm just going to take away the 44 from both sides. So we get 2 equals c, or c equals 2. And we can put that into our equation. And that is our answer. So it's going to be 11x plus 2. Y is inversely proportional to x means that y is proportional to 1 over x. And I'm going to change that for an equal sign by timesing the right hand side by k. And k represents our constant. And we're told that when x is 5, y is 10.8. So I'm going to fill those in. I'm going to substitute those in to be able to find out what k is going to be. So it'll be k over 5. And we're going to be solving this. Let's get my lines in. And solve it, I just times by the bottom of the fraction. So times both sides by 5. And we're going to end up with 50.4 is equal to k. So k is 50.4. I'm going to rewrite this equation here, but we know what k is. It's 50.4. We're asked to find the value of x when y is 9. So we've got 9 equals 50.4 over x. And whenever in this situation here where we've got the unknown at the bottom of a fraction and we've got it equal to a number, what you can do here is actually just swap these around. Effectively we're timesing both sides by x and dividing both sides by 9, but it does really help us out here because it just says that x is equal to 50.4 over 9. We can just do that on the calculator and it gives us 5.6. So here we're just adding the column vectors. So we're going to add the tops, so 2 plus the 5, and we're going to add the bottoms, minus 4 plus 6. 2 plus 5 is 7, minus 4 plus 6 is 2. So our answer will be 7, 2. So the first thing we notice is the coefficients of the x's and the coefficients of the y's are different. But if we look at the y's, they are very similar. So we've got 3y and we've got 6y. So all we need to do is times everything in the top equation by 2, and then they'll be matching. So we're going to write out the first equation again. And what we're going to do is we're going to multiply everything in it by 2. And so I'm going to write that equation again, just so we can match up the equations nicely to be able to do our simultaneous equations. And I'm going to write the second equation just as it is, because it's already 6y. And get my bubbles in, because obviously we're working downwards. Now we're either going to be adding or subtracting these, and the way of telling is looking at the sign before the 6y's, the matching coefficient, and if they're the same, then we subtract. If they are different, then we add. Now these are both the same, they're both positives, so we are going to be subtracting. So we're going to subtract the top ones from the bottom ones. 10x take away 6x is going to be 4x. 6y take away 6y is nothing, which is good, because if we're left with any y's here, that means we've made a mistake. And 70 take away 54 is 16. And let's get our lines in, because we need to solve this last bit by dividing 4 both sides. And so we've got x equal to 4. Now that's only half the job, because we need to find out what y is. So what I'm going to do is just copy this first equation, but substitute in the value of x, which is 4. So 5 times 4 plus 3y equals 35. Get my lines in. And 5 times 4 is 20, so I'm going to take away 20 both sides to get rid of the 20. So we've got 3y equals 15. And then we're going to divide by 3 both sides. So we've got y equals 5. Now we can substitute in the values into the second equation. So 6 times 4 plus 6 times 5 does equal 54. So to answer this question, you need to just know the answer off by heart. There is a diagram that can help us actually get there. And if we just draw a right angle triangle and put the lengths as 1, we've got right angle here, we can use Pythagoras, a squared plus b squared equals c squared, to work out the fact that this is going to be root 2. Because it's an isosceles triangle, this angle here is going to be 45 degrees, and same with the bottom right one, but we're not interested in that. When we label it with our marked angle here, we've got the adjacent is here, and the hypotenuse is here. Now we know from trigonometry that cos x equals a over h. The angle is going to be cos 45, and a is going to be 1, and h is going to be root 2. Now this is a bit of a strange one with 1 over root 2, because we need to actually be able to rationalise the denominator. And basically what that means, if you haven't done surds yet or you aren't doing surds, is you times top 1 by root 2. And so we end up with root 2 over 2. So if you ever see 1 over root 2 is absolutely fine as an answer, but if you ever see the answer as root 2 over 2, the two are actually exactly the same. So writing 1 over root 2 is fine, or writing root 2 over 2 is also correct. For this, you can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.